So number 51 is, I think, trickier than it looks. So it asks you which of those solutions is a buffer. Well, in order to make a buffer, you know you need a weak acid and a corresponding salt, or you need a weak base and a corresponding salt. So when I look at letter A, I see potassium hydroxide. Well, that's a strong base. I see the CH3 NH3Cl, and oh, that's a salt. So, okay, well, that's a good sign. I got a salt, but I got a strong base over here. I don't have a weak base, and I don't have a weak acid. But is it possible that I am going to create the weak acid or the weak base as I add the potassium hydroxide? Because my salt will do this, right? So what will adding potassium hydroxide do? Actually, I don't care about the potassium. I really just care about the hydroxide. So this will produce a weak base. So this has potential, but it all depends on the number of moles of each. So if I've got 0.1 molar of this and 0.1 molar of this, well, if I do a before and after table, I really should be using moles, but since the volume isn't changing in the problem, you can use molarity just this once. Afterwards, I'm going to end up with just weak base. So all my salt will be gone. So I can't have a buffer with just weak base. So A is not a buffer. Okay? The only one that's kind of, I would say, somewhat obvious is B. In B, you've got potassium hydroxide, which is a strong base. And then you've got C3NH2, which is a weak base. Well, there's no possible way to make a salt. You've just added two bases to a solution, so not a buffer. Okay. Oops. C is, again, has some potential. So we could go a little bit quicker this time around. Still going to write it out. So the hydroxide is going to react with the salt. Okay. Now in this case, beforehand, I've got 0.1 molar, and I got 0.2 molar. No, the other way around. That's good to label. I've got 0.2 molar of this, and I got 0.1 molar of that. So afterwards, I will have no salt again. I will have weak base, but a strong base and a weak base do not make a buffer. So not a buffer. So if I was guessing, I would guess D, but you never know. They might be jerks, and maybe none of them are buffers. So once again, OH is going to react with This time I've got 0.1 molar of this, and I've got 0.2 molar of this beforehand. So afterwards, this will be gone. I will be left with some of my salt, and I will have created some weak base. So D is a buffer. Yay!